So, like many of you suggested, the computer is now in a Faraday cage. This is aluminum mesh. Pretty fine. Fine enough for magnetrons, or actually, rather, microwaves. Not to be able to pass through. So, hopefully, we won't experience as much interference with this. But as backup to that, I also had some spare mesh, and I just went ahead and I just put it all the way around every single one of the magnetrons, which are the things that produce the microwaves. And hopefully with this we won't be able... Oh, I missed this one. Okay. Interesting. But hopefully this will actually help reduce some EMF as well, because of course we know microwaves reflect off of metal. They don't go through metal. So before, they probably were coming off of these, just some residual ones, and then bouncing off of this metal here, then bouncing off of that metal, and like getting back to the computer. But even if they do escape this is enclosed now all the way around in the metal mesh. So we'll see how that does. I also did a few other minor upgrades. For example, I made the vacuum hooked up to the computer system, as well as a solenoid, so I can just press one button and this valve will open, and so will the vacuum pump turn on at the same time. That's pretty cool. And I also did the same thing for this valve here, for the feed valve. I can press a button on the computer, this will open, press a button, the air will release, this will close for the plastic feed. So we're going to continue to make this more and more automated and more computerized as we go, of course to a safe degree where there's always backups, but everything is looking good. So without further ado, let's shred a lot of plastic and get a run going. Thank you so much for watching. Those of you that want to support this project, go to Naturejab.com/donate. Your donations keep this project alive and running. If you want to also support this project while looking good doing it, you can go to Naturejab.shop and get you some merch, or Naturejab.com/merch. Get you some merch there. Like I said, support Mother Earth, look good doing it, contribute to this project. I appreciate you guys, and I'm glad that you're here to enjoy this video. Here we have 3 bucketfuls of mixed shredded plastic, or just about 6 pounds. Now this scale is off because I zeroed it out and then it turned off, so it didn't save the zero, but this container is about 2.7 pounds. So we're really at about about 6 pounds of plastic. Now this is a lot of plastic, so we have to get some oil from all of this. Well, let's get the slurping her up. We got a long way to go, and we're gonna have to mix quite a bit of carbon in with this.
Difficult, but doesn't get a lot of airtime, which is why it might be important for me to mention. We live in a world
Alright, it has taken an immense amount of time, but we got all the plastic finally loaded in the machine. It is a mother ton of plastic. Let's go ahead and turn the vacuum on. Boom, one click. And we got negative pressure being pulled. Another thing to add while the vacuum is running is I built a little box here for my recovery pump, to one, protect it from rain, but also to kind of help with the sound. It's pretty loud. I put some ceiling tile all in there. And on the back here, on the output end, I have fitted up a high pressure tri-clamp dryer here. There's silica and activated carbon in here. If I put this on the vacuum end, it's going to affect the vacuum too much. It won't suck a good vacuum. That's why I put it on the high pressure end. So hopefully that'll help dry some of the natural gas some more. I have been having some problems with the natural gas being pretty wet. So if you guys got some suggestions, leave them below in the comments. All right, so look at the power consumption. This is pre-running the machine. We're at 2.5 kilowatt hours, and that's after the shredding, after the vacuum. So we're gonna go ahead and turn on the recovery pump here. And by the way, guys, at this point in the video, I recorded everything as a time lapse, 2 times slow speed, so that I got to voice over everything. I also wanted to mention that the microwave leakage of the machine has improved immensely. Look, it's not even reading 1 microwave per centimeter squared, which before it was reading about 2 to 3 on average. But after I put that Faraday mesh around all the waveguides, it has boosted the amount of protection we get from microwave leakage. So that's amazing to see. The electronics are definitely doing a lot better. So this aluminum, or rather this microwave screen is actually made of aluminum. So 32 minutes into this run, you can see the pressure, the negative pressure, about -4 psi. And I know everybody's probably like, why not, inches of mercury? This sensor actually doesn't have inches of mercury setting. But anyways, looking at the sight glass, we can see that there was, clearly the vapors, but no oils coming over. The temperatures were pretty low as well for 30 minutes in. So at this point, I could definitely tell something was wrong. I also wanted to show you guys my infrared pyrometers. Now what these are thermometers that actually use infrared to measure the temperature. So these are able to, in theory, measure the internal temperature of the machine, of the plastic, instead of measuring just the body temperature. Now you can see we got one at 80°C there, and that's kind of lining up with the temperatures we just saw of the body temperatures. And you see I have 3 of them, one in the middle, one at the end, one at the beginning of the machine. And sometimes all 3 of them work fine, and I can get the readings. So we see we're trying to correlate, what we're seeing here to the external body temperature, which are the temperatures at the top there. But sometimes 2 or all 3 of them will go out like this because the microwaves interfere with them. And I'm trying to figure out what the solution to that may be, because unfortunately, even when I cover them in the Faraday mesh, as you see here, they still have that problem. So we've been running the machine now for quite some time, and it didn't get me any oil, so I actually ended up changing the pipe system. Right, so look at this pipe system. This pipe system, the condenser goes straight down versus the condenser going at an angle, and I actually got oil from this. And this is kind of like my most traditional way of making a condenser system, but it was just interesting to me to see, because it's like, in theory, especially being under vacuum and being sucked, it should not matter what the orientation of the condenser is, because the things are being sucked through. But yet, I wasn't getting oil no matter what I did, but now I have it going straight down and I'm getting oil. So there's really no other way to say it than to just be like, well, that's clearly what works. So I gotta adjust this system to where I can make this go straight down into this keg here where we collect the oil, right? So I gotta actually make this whole column a little bit taller. And then I'm also going to have it come down just a little bit of a slant and then go straight down into the keg. So this is really weird to me. Maybe you guys can explain it better than I can, but it just doesn't make sense why when it's going straight up and down like this, we are actually getting oil in a way in which is not the same when it's going down on a slant. I know the slant will, of course, make it a little bit harder for the oils to flow, but I wouldn't think by that much. So regardless, clearly this was a solution, and I'm just going to run with this for now because I honestly am getting desperate to make some oil from plastic after all these runs. So this is the new condenser setup. This is exactly how I said. You see it goes up pretty tall, comes down on a little bit of a slant, then goes straight down. This design was taken from the machine right before the explosion. This is exactly how I had it. The only difference is that it is now going into the keg. Now you can obviously see there's a flare, and that flare is actually having some of the natural gas come out. And it's, right now the natural gas is too cold. The machine just started, so it's not flammable yet. But I actually am having this machine run traditionally to start, just so I can have a pretty good baseline. But I can turn this valve up or it's off, and then plumb in the vacuum line to the recovery pump, and then I can actually turn this machine completely on vacuum mode once we start to see oils come over. But I'm doing the traditional run because I know if we can get oils to come over traditionally, then we definitely can get oils to come under vacuum. So we're only 7 minutes in. Like I said, the gas is way too cold to be flammable. In fact, I don't know what this gas is that first comes over. It might literally be just like some water molecules. But there is a gas, a very visible gas that's coming out. But like I said, if I go to light it at this point, it just is not flammable at this point in time. And I don't know what this gas is, right? So it actually is kind of beneficial not to run it under vacuum and have it plumbing into the tank yet, because we otherwise be compressing this ghost gas, you could call it. So you see I got all my PPE on here too, guys. I'm not playing around. So 16 minutes in, now it's flammable. Took that little amount of time, just 10 minutes after we saw, and then now the natural gas is flammable. So for future runs, I actually want at this point to be the time when I turn on the vacuum pump, or the recovery pump rather. And then, so we look at the temperatures, 140 on the inside Fahrenheit, that is. And you can see all the different temperature gradients here, mainly looking at the back body temperature, which is 90 C. The back body temperature being 90 C is the hottest point. That's where most of the plastic is. Now we can see the infrared pyrometer saying it's 60 degrees C, and we're trying to line it up with the closest place inside the machine, and the front body temperature is 55 C. Now the theory is that the infrared pyrometers are measuring the inside of the machine, which should always be hotter than the outside of the machine. And I'm showing here that the elbow at the top, that is the condensate temperature coming over, right? And so that's what we're looking at too, because that condensate temperature coming over should let us know about what time we should start to see some water vapor and some oil vapors coming over. Now looking at this natural gas product again, the flame, it burns pretty clean. I mean, it has some suds, but that's just carbon, and you don't really see much, crazy black smoke coming from it. So like I said, I would like to have this at this point go right into this tank, but I'm waiting just for the sake of experimenting with this run to make sure that we're going to get oils this time. So I'm going to wait until oils come over, for a matter of fact, before we turn on the recovery pump. But we are getting this natural gas already pretty early in the run, so that's good. I think the natural gas product is actually the most abundant with microwave pyrolysis. So 26 minutes in, and still getting natural gas. The flame is actually even cleaner. You see, before it was mostly yellow, now it's blue. And that's interesting to see. We can see a lot of vapor formation in all of the sight glasses, so that's awesome. And going up here, we actually start to see some little yellow coming from the condensers. Now, this might have been some stuff that was already in the condenser from a previous run. That's just kind of like melting and working its way down on this slant. But then you go up here, and this sight glass is actually before any condenser, and there's this yellow kind of just haze in the sight glass, as if oil's coming out. And that could have been in the pipe above it, but the condenser's below it. So the only way that could possibly be from something already existent is if it was from the pipe above it, which I don't think it was, but maybe, since I use these pipes, I don't clean them out super well before I, go ahead and, rearrange them. I can't really say, but if there is truly that yellow haze coming out already, that's pretty early. But you see, I have everything really well insulated, because we cannot physically get condensate to come over until every single pipe going up reaches a certain temperature. Now look, the infrared pyrometer went out. So like I said, guys, help me with that. I don't really know what to do with that, with the infrared pyrometers getting hit by the microwaves, because unlike every other sensor, which clearly is doing well and not being interfered, the infrared pyrometers are screwed right into the machine. So even if I put a Faraday cage around the outside of the sensor, the face of the sensor, which is measuring the temperature, is getting hit by microwaves from the inside of the machine. But look at the temperatures. Inside body temperature is over 100 C. Middle body temperature is 100 C. I don't think we're going to get condensate coming over until about, I'd say 60 C on the vapor output elbow, and then definitely at least 100 C on the vapor output pipe, which is at the base. So the vapor output elbow is up there, and that's going to be, like I said, the condensate temperature for the most part. So we need that thing to be about at least 60 C, I say, until we're going to get some condensate to come over, because everything has to be pretty hot, has to be pretty toasty. So that's just period. That's just how the science works with this. All right, so we're back here, and we've been running the machine some more, and you see the natural gas is growing even more. I also wonder why it is cleaner after the machine gets hotter, right? Why the flame is more blue now. But that's the interesting thing. I wanted to show you guys. These are the infrared pyrometers. I did put some Faraday mesh, this aluminum screen, fine aluminum screen, over every single one in the hopes of the interference not being as bad, but it hasn't helped, unfortunately. And like I said, it's because the front face of them is being hit directly on the microwaves. The microwaves are hitting it from the front. They used to be hitting it from the front, the back, and the side, but now they're just hitting it from the front. So we got to figure out how to stop these microwaves from diddying them so hard, right? Hopefully something can come about. Maybe I could put some little mesh screen on the front of them, but I worry that might mess up the temperature because they'll be taking the temperature of the mesh screen on the front face of them instead of the actual inside of the machine. But look at that natural gas flame. It just went crazy. But look how clean and beautiful it looks though. Come on, you gotta be real. That looks absolutely beautiful. 37 minutes in. And one of the infrared parameters came back online, 98C, pretty hot. So I think that is the front body temperature because look, the front body temperature on the outside is 93C, 94C. This is 99C. So the theory is the microwaves are always going to be hotter on the inside than the outside because the heat has to travel from the internal material and make its way to the body and conduct its way to the body. So that's my theory. So I would assume that the infrared parameter that we're seeing there is the front one, right? So anyway, going back up to this glass, you can see this yellow haze has actually grown quite a bit. So I'm assuming that this yellow haze actually is some genuine condensate we're seeing here. And it almost looks like oil is coming out already, but you can see water droplets forming. You see those water droplets falling. So the machine isn't really all that hot yet, 37 minutes in, but yet we're already starting to see some water droplets. Now, I will say, this is also very dependent on how much plastic you put in the machine. In my best run I've done in the past, which was 10 pounds on the machine, or what was that, like 4.6 kilos, we got oils coming over in 30 something minutes, but I didn't put that much plastic in this time. I put in an actual unmeasured amount of plastic, but it was only about 1.5 bucketfuls of plastic, so it couldn't have been more than about 2.5 pounds. But look at these temperatures though. The body temperature is very hot, well over the boiling point of water, right? So then you're definitely stepping into the boiling points of oils, you know, because gasoline comes over at about like a little bit over 100 C2. So you look at these things, and it just makes sense. Look at the output columns. I got the condensers hooked up too, so we can take a look at the condenser temperatures, because when you see the condenser temperature start to rise, then you definitely know that you gain some condensate. 43 minutes in, you see the pyrometer went out again. Look at the pressure, 1/4 of a PSI, so it lets you know like we're really forming some vapors. I had to extend this natural gas hose because the flame was just getting too big. It was going to start melting my valves and stuff. But like, look at the flame, big flame, beautiful flame. You see it's orange again. You know, it's interesting. It kind of changes, right? Sometimes it's blue, sometimes it's more orange, but the flame, regardless, burns pretty clean, other than being pretty sooty, right? A little sooty, slutty flame in it. So anyways, what we got here is I got this double condenser system. I got a condenser going down, and then the machine or the vapors, once they condense down from this condenser, right? I want to catch as many oils as possible. So they have to travel up pretty high. And it's going to come down on this angle and go down this straight condenser, fall in the keg, but then it has to kind of snake its way up to this other condenser, and it has to travel uphill. And when it has to travel uphill through this condenser, that's going to kind of catch most of the stuff, because once this thing gets put under vacuum, it's a completely different game. It's much harder to catch every single vapor, right? You have to have a cold trap and stuff to catch every single absolute thing. And then it goes through this filter dryer system over there. And then going over to this recovery pump, I know I spoke about this earlier, but I wanted to show you guys, I actually upgraded the clamps on this filter dryer and activated carbon catalytic converter here to have high pressure clamps, because I thought about it, I'm like, wait a minute, this tank over here is going to be compressed like to 300 psi. We need to put high pressure clamps on this tri-clamp thing so it doesn't blow up in my face, right? So we have activated carbon in there and silica. The activated carbon will help clean up the natural gas some more, get some of the things out, and then the silica will of course dry it, so we get some nice dry natural gas going right into the tank. So you see the natural gas is burning well. Like I said, I'd love to start capturing this now. It's going to help the energy and efficiency overall, but you know, this run we're just trying to make sure we make oil to begin with. And look, I saw the first little like slimy thing come over, a little gross looking waxy bit that might have already been in the condenser. It's kind of hard to tell. The condensers do hold on to quite a bit of stuff after the run, so you don't really know until the run really starts. But you see, we're starting to get some real condensate coming over now. Is that water? Is that oil? It's not so easy to tell yet. It kind of looks like both, but regardless, it's coming over. We're getting condensate, and that's great. As long as you keep seeing condensate and it keeps building up, that's all you got to see, because you know that at some point in time in the run, it's going to pick up to an immense degree. But you see, notice it's flowing down, but it's not getting into that bottom sight glass, and that's because, you know, it has to go through that last condenser that's vertical, and it's going to slow it down because it's going to get even colder. So, you know, you get a liquid like an oil, and you cool it down again, it gets even more viscous, even slower. So there you have it. So like this natural gas, I would love for this to be able to run the generator, right? If it could, and even supplement it in some way. Like, you know, maybe there's some way I can integrate it to where the generator could switch over to natural gas in like the last quarter of the machine when the generator doesn't have as many magnetrons on, or the machine rather doesn't have as many magnetrons on. So when we turn on that pump, we're going to suck this natural gas in. It's going to go right into this tank, right? And it's going to be compressed right away. And that could, in theory, go right to a generator as well, but it needs to be cleaned up and dried enough for it to be able to work, or it's just not going to burn well. So right now it's burning fine because there's not that much liquid in it, because it's not being sucked as a vacuum, but the recovery pump ups the amount of liquid in that tremendously. So looking back up at this sight glass, we can see there's more condensate coming over. You know, it looks like mostly water, but it's really starting to pick up and really starting to flow here, and that's amazing. That's what we want to see. So right now this sight glass is actually quite a bit cooler than that top elbow coming off, and that's why it's condensing up there. But at some point the sight glass is going to get so hot that we're not going to see any condensate coming from up there, and it's only going to be after the condenser. So you see now an infrared pyrometer came back online, 147C, and you can see that if we're trying to match it up with the body temperature or whatever, you can see that it might be the front body temperature again being 100C, because all the other temperatures are way hotter than that. So, you know, once again, that kind of lines up to my theory of the microwaves from the inside always being hotter than the outside of the machine. So at this point, you know, natural gas still burning, and we're starting to see more and more oils come down. You see not much in the bottom sight glass, once again for the same reason we were talking about. But you can see, look at that, we're starting to see big drops, big globs of oil coming down on this thing, on the sight glass. But once again, once it hits this vertical condenser, it's going to slow down even more, because it's going to get even colder, and it's going to get a little muggy and slimy, and it's going to kind of get stuck in there to some degree until some point once it starts to heat up a little bit on these condensers. So I can't wait to see how this thing runs when we put a substantial amount of plastic in here, because like I said, I just put enough just to see, because it takes so long to shred all this plastic. It's like, why would I want to shred all this plastic, take all this time to load it in, just to figure out that we're not getting oil, right? So we're going to do the next run, guys. Trust me, it's going to be absolutely crazy with how much bloody oil we're going to get, how much plastic we put in. I'm going to do my biggest run yet, like 20 pounds in this thing. What is that? That's 10 kilos, right? So it's going to be crazy. So you see the oil starting to finally come down, but it's slow. Like I said, my theory is correct here. Look at the flame. Flame beautiful. Flame still going strong. It's always going strong. In fact, it only really burns out a little bit in the beginning. That's why I'm like, we got to capture this, because there's this energy right now. You know, like, some people are like, oh, you know, maybe you should make it heat the machine up. And that's true. I could put it right under the machine. Now, you see I got the recovery pump on now. Just, you know, time warped a little bit, and look at that beautiful flame when it's being compressed, shooting out there. Beautiful blue flame. Look at that oil coming out, baby. Look at that oil coming out. Beautiful oil right there. Beautiful amounts. 1 hour, 15 minutes in. Everything is hot. Everything is hot. Look at that. I have it in millimeters of mercury here. But I'm going back to PSI. But you can see we are now operating under negative pressure after about an hour in. We got the gases coming out being compressed, and that will increase the flow of oil and condensate. Why? Because as the more, you know, when you put this thing under vacuum, more of those vapors are being sucked and moving through the condensers, sucked and moving through the whole machine. Those vapors are going to hit the condensers quicker, which is going to cause them to condense quicker into more oil. So you put this thing under vacuum, you should by every time and every means get more oil. And that wasn't happening before with my previous condenser setup, which I knew something was wrong, because it was like it felt like being under vacuum was giving me less oil, but it should be the exact opposite. So I'm just glad we got the issue fixed here. Clearly it's working. Look at this natural gas. We're already at almost 50 psi after literally just turning the pump on for about what, 10-15 minutes. So you see I closed that valve. Everything's working good. Okay, so we're 2 hours in, and we're still at about 2.5 negative psi. Look at the temperatures there. I have the machine currently operating on half power, because there's no point in putting power back in the base when all the plastic is now in the middle and near the end of the machine. Now I do want to notice, or let you know, the oil flow is starting to slow down. Now there's still oil coming out, but it is slowing down, and that is because there wasn't that much plastic put in the machine. So there's not that much plastic to make much more oil at a certain point of time in the machine. And we're still getting natural gas. In fact, the natural gas tank over here is at over 100 PSI. So that's doing good. And this is a big tank, so 100 PSI for that is a lot. And so right now the generator is running and we're pulling about, I believe it's 7,000 watts. Let's see. 5,600 watts. So 5,600 watts of energy being pulled versus the typical 9,000 that we're usually looking at when we're running this thing at full power. So it's half power now. And yeah, we're still getting oil. We'll still run it for a little bit, probably about 2 hours, 2 hour 30-minute mark before we'll turn it off. You know, it's kind of hard to tell when the reaction is truly done, but I would say we could tell it's done once this starts to rise quite a bit, because that lets us know not much vapors are being produced. All right, so we are 2 hours, 10 minutes in. The pressure is still pretty fine, so natural gas is still being made. I only have 3 magnetrons on. However, look at the oil flow, completely stopped. That kind of lets me know that at this point, most of the plastic is pretty much done in the machine. We've been having the blades spinning too, so, you know, at this point, we're gonna go ahead and turn the machine off. Temperatures, they are still rising a little bit. We're gonna turn it off though. I don't think there's much of a point of having it on anymore. I didn't put that much plastic in, so 2 hours sounds about right for how much plastic I put in. Obviously, there is still some natural gas. And we will keep the recovery pump on for just a little bit to get the rest of the natural gas out. Right now, the recovery tank is sitting at, as you can see, it's almost 150 PSI. It's about 135 right now. 130, 135. So this was a good run. Got a decent amount of oil. And we're gonna see at the end, of course, open up this valve, watch that stuff pour out. But you can see that the side glass is really starting to get this really thick, cloggy stuff. And that's primarily probably because of a lack of heat, or a lack of continuous building heat. Simply because, you know, the reaction is over now. So we're gonna go ahead and turn off the recovery pump. Because at this point, I cannot open this machine with it still being under vacuum, or it could blow up. Because there's a whole bunch of flammable fumes in here that are hot, and then if oxygen gets sucked in enough of it, it will create an explosion, and it's an explosive environment, and blow my black ass up again. So I'll go ahead and turn off this recovery pump, so that way we can figure out what we're gonna do with these oils. Overall, a very successful run though. So you and I both know that is an underwhelming amount of oil. In fact, I know that there's oil in that keg that did not come out. So at this point, I hooked up my argon tank and I tried to push in some argon in the hopes of maybe that'll make some of the oil come out. Not to any luck. So unfortunately, this keg setup probably only will work the best when there's mass amounts of oil, like gallons and gallons in there to help kind of put some pressure on the internal liquids to help push it out. This will suck though for measuring, because if I want to know like how much the exact liter quantity I'm making per run, it's gonna be tough to know if this thing is giving me problems like this. So you guys, give me some suggestions. What can I do to make sure all the oil comes out? I was kind of shaking it a little bit. You see some of it's coming out. So I know there's oil in there, way more than what we got out. This is just how much could come out. So I went ahead and poured it in this glass beaker here because, first of all, of course, I wanted to see how it looked. Now notice how like just muggy this thing looks. And I also wanted to see how it burned. Now, interestingly enough, the oil naturally separated from the water. We didn't get water coming out of the keg, so that's how I know that we're not getting all the liquids to come out. So it naturally separated inside the keg, which is kind of cool, a separatory funnel. But it's very muggy looking oil. Of course, that's okay because we distill it anyway to make it more pure. But look at how it burns. It catches very easy to a flame. It lets me know there's some gasoline fractions in there. But it doesn't just blow up. So there's some gasoline in there, but I think this is mostly heavier fraction hydrocarbons. So look at how it burns. Not much black smoke to come from it, so it burns, I wouldn't say bad. I would say it burns pretty good. And you see, I went over here, and there was still some drips coming out of this valve. So guys, like I said, let me know. Like, give me some tips. So I put a little bit of oil in this same bowl here, and I lit it for a short video, and it's still burning, and it's been burning for the past almost 5 minutes now. So what that lets me know is that there's heavier fractions in here, such as diesel and jet fuel, because it's burning for a long time. But there is obviously some gasoline for it to be able to catch to the flame so easily like it did. Now, I'm going to have to move this so it doesn't start to burn this table, because this is rubber and this metal can get too hot. But I just wanted to say that because you can actually see it boiling under there. So this is probably, like I said, it's definitely made up of mostly heavier fractions, because if this was a cup of gasoline like this, it would have just gone up and gone down just as quick. Alright, so let's take a look at the natural gas. In this tank here, the recovery tank, it got over 100 psi of gas. It's about 120 psi in this big tank, so it's a good amount. So I would say overall with this run, you know, it was pretty successful. I know there's a lot more oil in that tank. Something interesting about the oil that came out the tank is it was already separated from water. It was just pretty much pure oil. And I had a kind of set up like this before, where I had a bottom drain on a tank. And the same thing happened with that tank too. On my Mark IV design, every time I pour out the oil, it was pure oil, and it had that same yellow look. It was no longer oil and water, like kind of like a 50-50 mix. So I know we got way more oil than what we've got, but it's all right. We're going to do a bigger run later, next time. Way bigger run, put in about 15-20 pounds of plastic and get a ton of oil. But let's see how this natural gas flame burns here. Wow. So the flame is almost invisible. It's so clean. It burns so well. There's no soot. There's no smell to it. There's a smell to the natural gas before it's burnt, but I'm saying like after it's burnt, there's no smell. It's hot. It's a hot flame. It's burning really well. So I think that dryer system I added onto the recovery pump is doing wonders, and I think this fuel will actually work really well in the generator. We'll have to see though. Thank you so much for watching. Those of you that want to support this project, go to Naturejab.com/donate. Your donations keep this project alive and running. If you want to also support this project while looking good doing it, you can go to Naturejab.shop and get you some merch, or Naturejab.com/merch. Get you some merch there. Like I said, support Mother Earth, look good doing it, contribute to this project. I appreciate you guys, and I'm glad that you're here to enjoy this video.